In this session, let me deal with corona and its effects. Okay, two things I would like to tell you before starting this. One thing is, once this discussion is over or about to be over, we are about to connect this particular thing to a beautiful, very beautiful interview question related to synchronous machines or machines. You would enjoy it. And second thing is quality. Okay, because if you go ahead with formulas, okay, of course we are going to deal with formulas also, because those are going to be empirical formulas. In the sense, you cannot derive that. Okay, so the moment empirical formulas are there, those empirical formulas has to be taken. If this increase, this will reduce. If this reduce, if this will increase, some kind of discussion anyway will be there. Okay, but before that, we should get a feel, right? We should get a feel of corona. Means inside the corona, what is happening actually. If you get a feel, with feel, if we study, we don't forget. Okay, anyway, let us see. First of all, during night time, if you see the high voltage transmission lines, around the transmission line you will see kind of bluish white color kind of tinge around the conductor. You will observe. Okay, you will observe transmission line, you will observe. Now let us see what is corona. Okay, corona is nothing but self-sustained electric discharge. I repeat, self-sustained. Okay, it means it should be sustained. It should be sustained. Self-sustained electric discharge or intensified localized, okay, ionization of air around the conductor is nothing but corona. Anyway, we don't want a kind of definitions and all. Forget about it. Okay, now let us see. If I have conductor here, okay, if I have conductor here, I know around this particular conductor we are going to have self-sustained electric discharge. Okay, kind of, if I take conductor like this, okay, if I take conductor like this, our electric conductor, around this conductor, air around this conductor will be ionized and air also will participate in the current flow. Okay, when air lose its voltage blocking capabilities, okay, when air will lose its voltage blocking capabilities, because any supply voltage gradient or electric field intensity is more than breakdown voltage, okay, or dielectric strength of the air, then air will lose its voltage blocking capabilities and it will behave like electrical conductor. Okay, so what is that? Under NTP conditions, under practical conditions, from formula point of view, anyway we are going to see later. First of all, let us try to understand corona. Okay, under NTP conditions, our dielectric strength of the air is 30 kV per centimeter. Okay, this is going to be maximum value, or if you think of RMS value will be 30 kV divided by root 2, 1.414 is going to be 21.2 kV per centimeter. Okay, now around the conductor, see here, around the conductor, because electric field intensity will be maximum on the surface of electrical conductor, already I know. Okay, so on the surface of electrical conductor, if voltage gradient is more than 30 kV per centimeter maximum, then what will happen? Air around the conductor will become electrical conductor, and it also will participate in the electrical current. Now, air is under isolated conditions. Air is an insulator, stable. Okay, if you give too much voltage gradient, then what will happen? It has to participate in electrical current, meaning that electrons has to be taken out of the molecule. Then once electrons are taken out, remaining are going to be ions. Now see here, if I see currents are flowing in this direction in our conductor, our air conductor currents also will flow in the same direction, because we have to understand how radio interference is coming, how ultraviolet UV radiation is coming, how that bluish tinge is coming, or how that harmonics are coming. We have to understand, right? Anyway, means these particular things, ions. Okay, so these particular ions if you think of positive ion, it's going to have complete nucleus, right? So these particular ions, bombardment will happen on the conductor. Okay, so bombardment are going to happen on the conductor, okay, such that because of bombardments, what will happen? If that bombardments are going to happen in the audible range of frequencies, 20 Hz to 20 kHz, we will be able to hear the hissing sound. Okay, so first effect is hissing sound we will be able to hear. Hissing sound we will be able to hear. Now, because of bombardments of ions around the surface, definitely erosion will be there on the surface. Okay, so surface erosion will be there on the conductor. Surface erosion. Okay, erosion will be there. Means on the surface of the conductor, meaning that at starting while installing the transmission line, my surface of the conductor can be smooth, but after time to time, because of this erosion, my total surface of the conductor will become slowly rough because of corona. Okay, now if I think of voltage gradient, what is there on the conductor surface? Okay, so if I think of my voltage gradient on the surface, is this. Okay, so this is going to be voltage gradient or electric field intensity on the surface of the conductor. Okay, now if I think of this particular corona, okay, or kind of air around it, maybe air around it will break down, okay, when voltage gradient is more than 30 kV per centimeter, because with this particular analysis you will get a feel. Okay, now see here, if that particular, okay, 30 kV per centimeter is here, 30 kV per centimeter is here, then what will happen if you think of our ionization of air? Okay, so when the voltage is less than 30 kV per centimeter, or when voltage gradient is less than 30 kV per centimeter, you are not going to have any ion discharge here, electric discharge here. Okay, so from here to here you are not going to have any discharge, from here to here you are not going to have any discharge. Okay, because my supply voltage or voltage gradient around the surface is less than 30 kV per centimeter. Okay, then what will happen from here to here? No current will flow. From here to here current may increase and after decrease. From here to here current will be zero. From here to here current will be zero. This particular current I am not speaking of conductor current, but rather than that I am speaking of corona current, discharge, electric discharge. Okay, so from here to here, the moment my supply voltage or voltage gradient at the surface of the conductor is more than critical voltage or critical disruptive voltage, means those things we will see later. Okay, as of now under entropy conditions this is 30 kV per centimeter. Now means if voltage gradient on the surface is less than 30 kV per centimeter, you don't get any harmonics. Oh sorry, you don't get any discharge. But if you have more than 30 kV per centimeter, here discharge will be there like this. Okay, now this blue line, if you think, okay, kind of corona discharge or whatever it may be, kind of corona discharge. Okay, now if you see corona discharge, this corona discharge, is it sinusoid? No. Okay, it is non-sinusoid. If you give this to Fourier, he will divide the total components into multiple frequency components. Okay, total real thing into multiple frequency components. Now already I discussed about the frequency spectrum. Okay, so if I think of increase in frequencies, first thing will come power frequencies, after that radio frequencies, after that infrared frequencies. Okay, after that red, okay, kind of, okay, and after that violet, and after that ultraviolet, and after that maybe X-rays, can be gamma rays, can be cosmic rays. Okay, so see here, the moment you give this particular blue component to Fourier divides it into multiple frequency components. Okay, so the moment it's non-sinusoid, from power frequency point of view, the moment power frequency in India is 50 Hz. Okay, maybe 150 triplet harmonic will come, maybe 5th harmonic will come, maybe 7th harmonic will come, maybe 9th harmonic will come. That is our power frequency range. Okay, so from power frequency range I can say that surface erosion will be there. From power frequency range I can say that harmonics will be there. Harmonics in currents or voltages? Currents. Okay, currents will be there, kind of triplet harmonic, 5th harmonic, 7th harmonic, some kind of currents will be there. Now let us think of when the frequency range is more, because this non-sinusoid I have given to Fourier and Fourier split it into so many frequency components. Now the moment power frequency range is crossed, you are going to get radio frequency. Okay, so radio frequency means radio frequency is nothing but the frequency by which you are going to transmit radio signals. Okay, but here radio frequency is coming into picture because of this non-sinusoid. So radio interference will be there. Interference will be there. Okay, about that one by one we are going to see in detail later. Now next thing is, if you think of maybe somewhere here blue. Okay, so means of course significant amount, because corona means to analyze corona everything is going to be empirical formulas, but there is no specific derivation and all. Okay, by using maybe testing data they developed some formulas. So significant amount will be there here already, we know, third harmonic, fifth harmonic. After that significant amount will be there here, and after that significant amount will be there here. So it is going to give bluish white color, because this is electromagnetic spectrum only, no? Okay, so fifth thing is bluish or whitish blue or whatever it may be. Okay, bluish white color will be there, which we can visually see. That's what we have seen in our previous one. Okay, now sixth thing is, see here blue is there. After that means ultraviolet radiation will be there. Okay, only given reality is this only, but the moment this reality is non-sinusoid, and if you split into so many frequency components, each and every frequency component if you see, ultraviolet radiation will be there. Okay, and after that see here, coming to our mechanical thing here. Okay, air around are ionized, and because of that my electrons are coming out, remaining are going to be ions, bombarding of ions. Okay, so chemically speaking, that particular air is going to go through chemical action. Okay, so what are the main components which are there in the air? Okay, so oxygen will be there, nitrogen will be there, carbon dioxide will be there, and remaining many other things will be there. If you think of oxygen, because of this chemical action, because of bombardment of ions inside and all, means you are going to get O3. That is chemical action. We are not chemical engineers. Frankly, I don't know the equations for it, frankly. Okay, so ozone will be formed. About this only we have beautiful interview question I'm going to discuss. Okay, next thing is 8. Okay, next thing is my nitrogen also will be affected because of this chemical action, or because of this action, chemical reaction, whatever it may be. So nitrogen will become nitric acids and some salts, okay. Now after that carbon dioxide will be split into carbon. Okay, and that particular carbon deposits will be there on surface of the conductor. Okay, carbon deposits will be there on surface of conductor. Okay, so because of nitric acids, kind of corrosion effect will be there on top of the conductor. Okay, because acid, corrosion will come, right? So corrosion effects will be there. And anyway, because of these two, you can observe some kind of white powder. Once maybe at starting, while installation, you will not have any kind of white powder around the conductor, but after some time, because of corona, white powder depositions will be there because of salts or whatever it may be. Deposits will be there. Okay, so these are the effects. Now let us think of each and every one. Okay, so first thing is hissing sound. We need not analyze that hissing sound, okay, because we are not sound engineers. And surface erosion will be there. Okay, because of surface erosion time to time. Okay, so after some time, once because of surface erosion, once the conductor outside material become eroded and become irregular, then gradually kind of corona loss will increase, and all we will see with the equations and all later. Now if you think of harmonics, triplet harmonics is the problem. Okay, so if you want to know more about this directly, kindly watch the videos of transformers, three-phase transformers. We analyzed harmonics. Okay, basically triplet harmonic component of each and every phase will be in line. If I think of three-phase wires, okay, IA, B, C, triplet harmonic component of this at one instant is 1 ampere. At the same instant this also will be 1 ampere. At the same instant this also will be 1 ampere. Okay, such that 3 ampere should go. For example, if ground wire or neutral wire is not maintained, okay, then if it is, for example, in three phase, what will happen? If it is maximum, okay, it is half of negative maximum. This is, if this is positive maximum, this is half of negative maximum, this is half of negative maximum, such that IA plus IB plus IC equal to 0. If it is fundamental or fifth or seventh, Okay, just I'm trying to connect it, that's it. Okay, now after that, if you think of triplet harmonic, means where at one instant if this is 1 ampere, at the same instant this also will be 1 ampere, at the same instant this also will be 1 ampere. If you have ground wire, it is going to be 3 into 1 or 3 amperes. If ground wire is not there, if ground wire is not there, or if ground is not properly maintained, in that condition these currents cannot flow because return path is not there. No, these currents cannot flow. Okay, so because of lack of triplet harmonic currents, triplet harmonic voltage will be induced. If you want to have clear picture about this, just go through the videos of transformer, three-phase transformer harmonics. Okay, so triplet harmonic voltage will be induced. Triplet harmonic voltage will be induced. Okay, now next thing is radio frequency interference. Okay, so if you think of this interference, roughly 0.5 or 0.6 to 1.5 or 1.6 megahertz, maybe let me think 0.5 to 1.5 or 6 megahertz frequencies will be there. Okay, significant frequencies, what I want to say is, okay, now if any operating means your communication line, okay, because the moment you have power line, around that if you have communication line, basically this interference, is it inductive interference, electromagnetic interference, or electrostatic interference? Electromagnetic. Why? Because electrical current is having harmonic components. Okay, it is not electrostatic interference, already you know, right? It is going to be electromagnetic interference, or this particular interference is going to be inductive interference because of currents only, no? Okay, so my transmission line is going to have harmonic current and adjacent communication line is there. So communication line, because of this inductive interference will be there and range will be of this much. Okay, now if any apparatus which is not in the range of this kind of microwave, okay, or TV signals, okay, microwave kind of relays and all, okay, or TV signals will not be interfered, or kind of radar signals will not be interfered. Okay, but if you think of radio signals, it will be interfered. Okay, now radar signals and all will not be interfered because the signal frequency range is different. Now bluish whitish or whitish blue color will be visible, that is fine, we cannot do anything, and ultraviolet radiation will be there, that is fine, we need not analyze that. Okay, and O3, about ozone we have to discuss a bit. Okay, first of all, already we know that electric field should emanate radially with respect to the surface if it is electrical conductor. Okay, so if I have electrical conductor around, my electric field intensity should be radial, means electric field intensity or electric field should be emanated radially such that it should be 90 degrees with respect to the surface, and here it should be 90 degrees with respect to surface for pure electrical conductor. It is 90 degrees with respect to surface, it is 90 degrees with respect to surface, something like this. If I have irregular pattern, for example, let me consider like this. Okay, charge is there inside, so my electric field intensity or electric field should emanate radially with respect to the surface. If it is electrical conductor, so radial, okay. Now here if you see, the moment you have any sharp edge, okay, so the moment you have any sharp edge, electric field intensity there will be more. Okay, so electric field intensity here or voltage gradient is going to be more if you have sharp edge. Okay, now about this from formula wise we will see later, but anyway, now let me connect this with interview question. Okay, so the moment you have sharp edge and voltage levels are more, okay, when the voltage gradient levels are more, if it is beyond 30 kV per centimeter maximum or 21.2 kV per centimeter RMS value, definitely kind of corona will come. Now can I say corona will be there only in power systems? No. Wherever you have more voltages or wherever you have more sharper edges, you are going to have corona. Okay, now from machine's point of view, which machine is operating at high voltages? Transformer, because if I have 220 kV by 400 kV transmission line, who will transform from 220 kV to 400 kV? Transformer. So if you want to analyze corona from machine's point of view, first transformer has to be analyzed. After that, next level of voltage will be maintained by alternator, roughly 11 kV. Roughly 11 kV. So next voltage level is alternator. Okay. Next level of voltage is induction motor, high tension motor, here HT motor. HT motor, which may operate at for 5.5 kV, something like that. And next level of motor is going to be induction motor, which value is going to be 440 volts, line to line. Forget about it. Now, if you think of transformer, corona means while designing a transformer, corona need not be analyzed much, because my transformer, if I have core like this, my winding is going to be like this, meaning that my winding is going to be, you don't have any sharp edges. Okay, so you don't have any sharp edges. It is kind of cruciform core, forget about machines and all. See here, it is going to be cylindrical. Okay, so you don't have any sharp edges. But if you think of alternator, sharp edge will be there. Okay, once I complete this discussion, then you will understand, okay, this is the interview question. Okay, so alternator winding is going to have back-to-back connection or not? Yes. Okay, alternator winding will be forward conductor, back-to-back return conductor. Okay, so and here if you observe, sharp edge is there. Okay, so the moment sharp edge is there and voltage levels are 11 kV or 12 kV or maximum up to 18 kV. Okay, so voltages are significant, but sharp edge is there. That's the point of interest. Okay, so the moment sharp edge is there, then what will happen? Ultimately, because of corona, of course, such a huge corona may not occur. Okay, but because of corona, ozone will be liberated. Okay, now that particular ozone may save our atmosphere or whatever it may be, but in our machines our effect, because means in transmission line, okay, ozone will come, that's it. Nothing is going to happen because of ozone, maybe kind of some corrosion or something like that. Okay, now if you think of O3 is generated at the back-to-back connection, then what will happen? Means here, means back-to-back connection. If you see here, forward conductor, back-to-back, return conductor, adjacent coil will be there, no, again back-to-back, again back-to-back, again back-to-back. Okay, so at the end here, many back-to-back connections will be there. Now, proper insulation will be there or not? Yes. So for example, this is the insulation. Maintained. Okay. Now because of O3 liberation, our material will, insulating material will become hard. Insulation material will become hard. Okay. Now insulation will become hard. Now, what is the problem if it is hard? No problem. But if you see our slot, okay, our slot will support this mechanically from here to here, because slot will be there. Inside the slot, conductor will be there. Okay, so forward path, total forward path, slot will be there mechanically. Back-to-back connection, slot will not be there. Slot support, mechanical support will not be there because it is in the air. And return path, you are going to have slot, iron slot. Okay, so from here to here mechanical support will be there, but here to here mechanical support will not be there. Back-to-back connection. Now then what will happen if it is short circuited? Okay, short circuited or huge current flow. Okay, so when at any point of time current flow is huge, then kind of mechanical stress will come because of proximity effect and all, we will see later. Okay, I might have discussed it previously. Okay, so because of huge currents, sudden rise of currents because of short circuit and all faults, then what will happen? Here mechanical stress will be there. Because of mechanical stress, back-to-back connection windings are going to have some vibration. Because of that vibration, already insulation became very hard, and kind of it will become into small broken pieces. Okay, now because of this mechanical stress, then what will happen? It is going to give pitting of insulation. In the sense, some small pieces will be dropped out. Okay, then that used to be the biggest problem at starting while designing alternator. Okay, then how to protect it? Ultimately, when mechanical stress occurs, If you stop vibration of this particular back-to-back connections, then it's okay, because even though metal become hard, means at least insulating metal will be inside the coil only, okay, such that insulation fall down will not happen. But at the same time, from here to here, iron slot is there. Can I use maybe iron boxes here, okay, such that vibration can be stopped? No, because if I use iron, if I use iron boxes to support back-to-back connection mechanically, my field flux or flux will go through this, because that is iron. But intentionally, at any cost, back-to-back connection should not have any flux. So what has to be done? Rather than iron, use aluminum boxes. Okay, so interview question here is, why back-to-back connection of an alternator, okay, will be supported by aluminum boxes? Very popular, okay, NTPC and all. Why? In order to limit pitting of insulation. Why pitting of insulation is happening? Because insulation is becoming hard and it is becoming into broken pieces. Why? Because of ozone. Why? Because of corona. Okay, anyway, come back to here. Okay, now because of nitric acids or carbon deposits, nothing will happen to the conductor, at least for some time. After that, maybe maintenance has to be done and all. From equations point of view, okay, and again from questions point of view, gate point of view, IS point of view, again we will see in the next video. Okay.